universal. So please put your hands together for these three. They will be talking about reliable media reporting in an ever-changing data landscape. So please give a big round of applause. Over to you.
Thank you so much, everybody, for coming to our presentation today. NBC Universal and OnPrem Solution Partners did a data and systems exploration project together, and we're going to give you some more details about that project today.
Good morning. My name is Eric. I work at NBC as a senior technologist in the creative content protection team. And what that really means is I either create or integrate new technologies in fingerprinting, watermarking, and forensic analysis of content.
Can you guys hear me okay without the microphone? Man. I will honor the microphone. I'm Rachel Kelly, a project manager with OnPrem, a consultancy, and we'll talk a little bit more about what that means in a couple slides.
And I'm Josh Andrews, the data analytics and technology lead at OnPrem. And like Rachel said, we'll tell you a little bit more about our firms in a minute here. So as I said, NBC Universal and OnPrem did a systems and data exploration project together. We're going to give you some background and detail about the methodology that we used in the project, and also some of the technical information, because we know that this audience is really interested in getting into the nitty-gritty about that kind of stuff. So first we'll give you some background on our two companies, then a brief problem statement. We'll move you through the approach, some background to the problem in more detail, the methodology that we used to approach it, and then get into the details of the data analysis. And finally, we'll talk about some recommendations that came out of the project, what NBC Universal has done and is thinking about continuing to do in terms of next steps, and then if possible, some questions.
So NBC is a large company. Maybe you all know that, but NBC is a very large company when you really look at how it's split up. Broadcast TV, digital-only content, film, and the theme parks, and then cable TV. So across all that, you have a lot of different types of content. Movies, TV shows, some of which that are live. You have sports, coming up, the Rio Olympics, which we also handle, just major events. And these are some of the domestic properties, but of course there are many international properties as well. And regarding the solution that we'll talk about today, we used MariaDB, ElasticSearch, SQL Server, and Cassandra.
So OnPrem Solution Partners is a media and entertainment technology consulting firm, and we have three major areas of focus. So first, we deal with business consulting, strategy, product roadmaps, all of those kinds of things that come up. When you think about dealing with technology, it's never just the technology. It's helping people to adapt to it, to deal with the change, and to manage it in such a way so that the whole organization is able to continue functioning smoothly. Then we provide technology leadership, customer relationship management systems. Rachel and I are part of the data and analytics practice. We have a very large digital supply chain practice around management and movement of media assets in companies. So you might think, well, particularly in this era, you have companies that are filming and recording digitally now. Most everybody's moving away from analog recording. So managing those very large assets as they're moving around in many different formats, and then all the marketing or promotional materials around those as well. So that's what's involved in digital supply chain. Finally, project management and systems integration services. And then applied innovation. So custom solutions, enterprise application development. We have 3 locations in Los Angeles, New York, and Austin. And in Austin is where we actually do a lot of our software development work and some of the heavier technical lifting around applied innovation. So a little background to what we were working on together. The Creative Content Protection Group at NBC Universal wanted to get into a little more detail around this process that had been growing organically over the years around asset identification and analytics of those assets, particularly when it comes to interaction and reporting and analysis with many vendors that all of this is integrated with. Because no man is an island, right? Everybody who's doing business these days has a ton of automated interfaces going on with other, not just internally in their own firms, but with external firms. So wanted to get a little better handle on what was going on with that. Our scope was first data with the streaming services, which are integrated with NBCU, and that for the content that NBCU has copyright on, tracking all that, making sure it's appropriately managed. And then also taking a look and cataloging the data solutions in place within the Creative Content Protection Group and also in other areas of NBCU that are not just as part of CCP. So our objectives coming out of the project were to develop a data strategy and figure out, where should this be going? How should it be? How can we help NBCU improve the already existing processes that they have around managing the streaming services metadata? And then also digging in and defining a data taxonomy. What are the common definitions of the terms that are being used? Can people come to agreement on those? Can we start writing them down? Not necessarily doing that exhaustively through the whole organization, because that would be a huge task, but at least figuring out the top 10 to 20 terms for that. Going in and doing some data profiling, which will give you the detailed info on that. And then also going through and just developing a data source list. In every project that we do, it's interesting. What we find is we ask, well, what are the systems out there? And as you ask, there's usually a first pass at those, but you go back, well, there's this system over here and that and the other two. Where are you pulling from? What's being integrated? So this was the background to the project that we were working on. So now let's talk a little bit about the approach. So I'll hand it over to Eric to talk a little bit more in detail about functional details at NBC.
So I just wanted to talk a little bit about what fingerprinting is. The fingerprinting process, much like what would happen if you got arrested and the police took your fingerprint, in the digital world, a digital representation of a file is a digital fingerprint. So let's say a 10 gig movie goes in and a file that's much, much smaller, 25 megs or so, comes out. And that 20 meg file is the fingerprint. And that fingerprint is then sent to partners. And most of the top sites that you can think of have fingerprinting integrated, so that when somebody uploads something into those platforms, the fingerprints attempt to match that content and tell what that content is. To go along with the fingerprints that are sent out to the different vendors, it's a great idea to send really good metadata along with the fingerprint. That is because once a match is made in those systems, that match responds with what that content is. And if you have that metadata incorrect, then your data is going to be incorrect. But there are problems with this metadata addition into fingerprints when you look at the scale of a company like NBC in regards to, well, for any company dealing with metadata at scale with duplicates of the data or quality. It's a very challenging thing for us to deal with. So you have the fingerprint, the metadata that goes along with it, and that may produce a match, a content match. And the content match just says, we've got your content, we know that we've made a match, and it depends on the business to determine whether that match produces a block. In other words, don't let somebody upload that content, or to just track the content. That's saying, just track how many times somebody uploads this piece of content. And to make sense of this entire process, the analytics from it, we've used different technologies. Cassandra for time series data, because the analytics coming back from fingerprint matches is perfect for that. Analytics summaries, that's summaries of all that analytic data going into MariaDB. Titled metadata, raw titled metadata, and operational fingerprinting data in MS SQL. And then ElasticSearch for a cache that allows human beings to actually look through it in the web interface. And we definitely find that open source solutions that allow easy proof of concept without getting into a contract first are our preferred way to go and are very helpful for us.
Thanks, Eric. So I'm going to walk you all through the methodology that we follow as a standard across any project like this, give you some of the stats on this specific project, and then at the bottom of this slide I've got an example of one of our outputs from our data profiling reports, and Josh will talk a little bit about the nuances with that. So our data profiling methodology, we have a standard 5-step methodology that we follow. So we use that here on this project. First, we interviewed our stakeholders to understand the key systems in place. We got access to those systems so that we could determine their purpose, verify what we learned in those interviews, and also establish the source systems for these key priority systems. And we then ran our proprietary data profiling reports across the priority systems to gather some fundamental metrics on each of them. And that's stuff like scale, percentage non-null, minimum and maximum. And so from those fundamental metrics, we gather, we find out the key places where, like, okay, that looks a little weird, let's dive into that a little bit more, generate more questions, and do a little deeper dive on those specific areas. So to bring up some of the project stats, we looked at about 20 different systems, we interviewed 9 stakeholders, and we ran data profiling reports on 32 different tables. And those reports, if we had been creating them manually, the effort is really determined based on the size of the table. So creating them manually would have taken anywhere from days to weeks, and you can see we only had 8 weeks for this project, pretty short time frame. So luckily our scripts are enabled with automatic, our profiling reports are enabled with automatic scripts, which let us run those reports in a matter of minutes. So that brought our effort down by a magnitude of 1 to 2. And so here at the bottom you can see an example of one of those data profiling reports, so you know what I'm talking about. Later on in this presentation, when I show you quite a few different tables that are subsets of these, and Josh is going to talk a little bit about the nuances in running those reports.
Thanks, Rachel. So whenever someone gives you a new data set, particularly if it's not just one table, but if you have a lot of tables, you start having questions like, well, wait a minute, how big is this? How many columns are there? How often are there nulls? Is there any sort of correlation between the data? Are the data types correct? In data typing, of course, that also gets into schema on read versus schema on write. Are things that are typed as integer or character, should they really be integer? What are dates? All those other things. And so we've written, you get into a database, you might start saying, well, select count star, so going column by column. That approach doesn't scale very well if you have tables with 200 columns and you have 100 of those tables to deal with, and you have to figure out the relationships and all of that. So what we've tried to do is automate a lot of that process and use database metadata where possible to help us make better judgments about what to do. So I know it's a little hard to see some of the detail on here. The slides will be available afterwards, but trust me, it shows you the database, the type of the column in the database. We pull it out, do some analysis using Python and Pandas and some other libraries to figure out, well, is it really that type? Could we coerce it to another type? Some summary statistics, standard deviation, average, min, max, other things. And we use the data type in the database to intelligently determine what sort of summary statistics we can actually calculate on it. Doesn't make any sense to take an average of a character column. It does, on the other hand, make a sense to take an average of an integer or standard deviation of an integer. So, and then finally, with this data set, we also ran into cases where explicitly we knew that integers were being used for date-time data types. And so, but we couldn't automatically tell for a given integer column whether that was the case or not. So we actually wrote code to go through and say, well, can we coerce this? And there were 4 or 5 different differing formats for date-time data types in the source. So we actually even said, all right, can we figure out what specific format it is? Is it YYMMDD? Is it, 4-year digits? Is it MMDDYY? Can't do that with 100% accuracy, but we can cut down a lot on the manual work we have to do.
Thanks, Josh. So to give you all an idea of the entire ecosystem that we are working with on this project, here's one of our final deliverables, which was a data flow diagram that takes our system inventory and maps out how all of these different systems that we encountered are related to each other. And so the entire diagram shows the entire ecosystem that we were working with, both internal and external sources. And then the rectangle in the middle, the gray rectangle, is just the systems at NBCU. And the blue rectangle are all the systems that are a part of Eric's team. And we are going to start today with the SQL server up there in the middle, which you can see is fed by all these upstream sources, both internal to NBCU and external. I'm going to show you some tables that are subsets of our data profiling reports and show some of those key highlights that came out of those. Okay, so as you saw, the SQL server is fed by these upstream metadata sources, and then it feeds into downstream sources as well as being used for different reporting capabilities. So our main focus in looking at this set of data, because it's really used to patch together this big picture view of everything that they're gathering from these different places to kind of give you an understanding of the world. And so we wanted to really understand the data quality, the source integrity, how frequently things are being updated, and of course the complexity of the data. Now, of course, for legal reasons and also for brevity's sake, we can't tell you, every single thing that we found, but we do have some exciting highlights to walk you all through today. So here is a subset of our data profiling from a table called release dates. So this is the dates that a movie or a TV episode or a live broadcast would be released, and kind of what platforms and where. And we ran into an issue here with data quality, which comes up a lot in metadata, especially in the entertainment industry. The first thing that I've highlighted is season number. So we saw season numbers that ranged from numbers to years, which is fine, but it wasn't consistent. So I have no idea if 2015 is that your first season or your 5th season. And then we saw other places like episode name where metadata just wasn't filled out. And we saw release dates that we knew couldn't be real. Obviously, there was nothing being released on New Year's Day in 1900. And we know that we're not planning as far out as the year 3000. And what happens there is somebody puts 3000 as a placeholder, right, because they're planning a release date for the future and they just haven't finalized it yet. So they know it's coming up. And again, that's fine as long as people are going back and cleaning it, right? It's really only a problem if those aren't updated later, because then you just get dirtier and dirtier data. So here we have 2 charts that really show kind of the complexity of the data and what we were dealing with. And the first one shows across these 4 different data sources, we wanted to look at, okay, of these sources, how often is one being used versus the other? What we were surprised to find was that instead of maybe a 25, 25, 25, 25 split, or similar, there were actually a couple of sources that were much more likely to be the source for any given record versus, this fourth one, which is just kind of like filling in a couple gaps, but not nearly as relied upon. And then similarly, looking at just titles, we looked at a set of titles, and we saw that the majority of them are coming from 2 different sources. And then plenty coming from just one, then there's this steep fall off, and then nothing is found in all 4 of those sources that we looked at. So to bring your memory back to the beautiful data flow diagram, we just talked about the SQL server, right? That feeds into Cassandra along with copyright match information. So the fingerprinting data and metadata around it that Eric was talking about. And all of that is grouped together and summarized and sent into MariaDB, which is then used for downstream reporting. And what we found with this data set is it really kind of tested our ability to adapt, because we thought, we'll look for different patterns across different video types, right? Maybe something that was officially uploaded by an NBCU brand, like a network, versus something that was uploaded by a user. And we actually couldn't get rid of our outliers here. Usually when you have a big data set like this, where you have a bunch of outliers, you can take them out and just look at your, kind of the middle chunk of your data. But that's just how this data is. We're looking at video views. Of course, Josh uploads a video of his cat that gets 5 views, and Eric uploads a video of his toddler that goes viral, and you have it's not as cute as his toddler. So we of course are going to have some videos with very few views, and some videos that legitimately do have billions of views. So again, I'm going to show you some tables. I know it's an eye test. Just know that this is a subset of our data profiling reports. And there are 2 things to understand about this. First, there's the data profiling itself, and then there's the issues with the data. So I'll just talk about the data profiling first. You can see, especially if you're in the front rows, there are a few blanks here, especially in standard deviation, min and max. So it's just like Josh was saying, it doesn't make sense to run standard deviation or min and max for a varchar field. Again, standard deviation doesn't make sense for dates, but min and max do. And so here's where the data profiling is intelligent enough to know the difference. And then talking about limitations in the data and discrepancies in the data. So one data discrepancy that I wanted to highlight was this field called reference length. So as Eric was saying with the fingerprints, right, there's a fingerprint for a certain amount of a video, right, and then when something else comes in and you want to see if it's a match, the reference length tells you how much of it is a match. So maybe I upload a video that's a minute long. What we were finding is that often the reference length would be longer than the video length, which doesn't make sense. If I upload a 1-minute video, the reference length should be 1 minute or less, not 2 minutes. We can't have a 200% match. And then in the area of data limitations, again, just one area to highlight was we only had the most recent upload date captured. And so if we wanted to look at, how long after we uploaded something did it take for a match to show up, and how many matches were in, the first 5 minutes versus the first 5 days versus the first 5 weeks. Well, a lot of times we would see that we would have a negative amount of time between the match and the upload date, because the upload date might actually be not the content might have been uploaded but not actually published and made available to be matched until a week later or sometime later. So now that we've talked about some of the details from the project, we're going to talk through our key findings and recommendations, and then kind of the outcome for NBCU. What does this all mean, and next steps. Okay, so obviously we can't give every detail about our findings and our recommendations. in general with projects like these, a lot of these things are non-disclosure, but we have a lot of things to share. And what we saw was that these findings kind of came into 3 buckets, and I'll go through each of these. So there were data challenges, there were tech challenges, and there were organizational challenges. And we see this in our projects quite a lot. The organizational challenges tend to be at least as, if not larger, than the tech or the data challenges. And that's just the nature of business. People and processes are going to be at least as complicated as the technology that you're putting in place. So to walk through each of these, I'll start with data challenges. You guys saw some of the data challenges that we ran into. There are gaps in the metadata, things that are not being filled out, discrepancies. And so generally our recommendation in these areas is better cleaning of the data. And specifically in this project, we, in the course of our stakeholder interviews, came across another metadata system that they could leverage to potentially fill in some of those gaps that we were seeing. So then next, in the area of tech challenges, you saw in the data flow diagram, lots of this data was coming in from external sources, and those sources are also enabling other organizations, not only NBC Universal, to report on these different things. And so they, for their own needs, they're going to have to limit the amount of data that they're pushing out. It's totally understandable, but it's something that's challenging for NBC Universal when they want to report on all this data. Maybe they're expecting 100 million rows to come back, and instead they only get 900,000 because they reached their cap on API calls that day. And those thresholds also tend to change, without telling anybody involved. So it can be a crapshoot. So our recommendation here was to try to be more selective in the data that was being pulled, and just write as clear and specific API calls as possible to kind of make sure that the data that was coming across was the highest priority, so that in the event that data is inaccessible, at least you have the most important stuff already on site. And so then to speak to the organizational challenges that we ran into, so there are a couple here that we've highlighted. We already talked about data integrity. The data itself, it's coming from all these different places. Those places, these teams, they have different priorities, and so they're just incentivized differently to keep this data clean in the manner that Eric's team would want it to be clean. And it's not that they don't care about data integrity. Everybody, I think, these days understands the importance of trying to keep your data clean and avoid dirty data. It's just that they might be more concerned about, this area of the data over here, and Eric's group is more concerned about this area of the data over here. It's just natural, you're working with different companies and different teams and departments. They're all going to have different priorities. We can't all prioritize everything all the time. So here, in general, when we run into these types of situations, we suggest improving the data processes, and here specifically we suggested adding an ETL element to better clean the data that's coming in, especially tailored to these different sources. And then finally, we ran into brand-specific workflows that ended up, again, with different data coming in from different groups. And so when I say brand, I mean like a network like NBC or Oxygen, or it could be like Telemundo, like a collection of networks. And what we saw there was that different brands, again, different people, different priorities, different organizations, different needs. So they might be focused on pushing out the content as quickly as possible without necessarily caring about capturing all of the metadata around that content. And that's part of why you saw so many blank episode names in the data that we were looking at. And so here our recommendation was that we put together a roadmap to clean up the data that was there already, so that we could report back to these brands on the things that they wanted to know, and then also establish a process to maintain data integrity on a go-forward basis. So now that we've talked through those, specific to this project, Josh is going to talk about some of our more general findings.
For the record, Harry the cat got more than five views. I think the internet runs on cat videos these days. So Rachel talked a lot about the specific challenges we faced working together in this particular project. I'd like to talk about a little more some wider challenges that we tend to find across all of our projects, both in terms of principles, like kind of patterns that you want to work towards, and pitfalls to avoid. So the first big point that, as I was thinking about this, that sprang out at me is with these kinds of systems, with any sort of data-oriented system, maintenance is the monster. And I was thinking about, trying to figure out over the last couple of weeks, why is that the case? And one of the answers that I've come up with is that in most IT projects, when you go pitch it to someone, you say, we want to do an ERP system, or we want to do a CRM system, or we want to just set up a system to do time tracking, or whatever it is. Usually, if you think about the costs start off high. There's a big kind of bump here. We got to, more people are moving to AWS, so hardware is a little lower, but implementation costs and all of that. And then you get the system deployed, you get through testing, iron out initial bugs, costs go down a lot, run and maintain. But with a lot of data systems, it doesn't work like that. The costs kind of start up, and then they just keep level. They keep growing because you keep having to deal with data cleanliness and integration issues and other problems like that. So maintenance is the monster, keeping it running in terms of costs and effort. Common issues from the technical side, you've rapidly changing platforms and frameworks. If you were running a traditional data warehouse and you set it up 10 years ago and it was working well, and you just started adding some more feeds and subject areas to it, great, it's working. And then all of a sudden you have Hadoop and ElasticSearch and other sorts of solutions come across the scene, and you start getting a lot of requests from other people to deploy those kinds of solutions, or at least asking, why can't you handle really texty, kind of non-columnar kinds of data in your warehouse? Well, now all of a sudden you have to keep your warehouse running, but then you also have to think about how to handle these other things and how to accommodate those needs. So it's tricky to keep, all of that kind of juggling at the same time. Need for continuous maintenance and always checking your data. You could have a totally reliable feed coming from someone else for a year. That means it's kind of like the stock market, past performance is no predictor of future results. Just because it was working for a year doesn't mean that tomorrow someone couldn't turn off that feed, change the format, or have even more subtle alterations to the values that you might not even detect. So keeping track of that's tricky. And then the non-technical side, Rachel's already talked a bit about incentives and cultures differing, so I won't belabor that point anymore. Data stewardship, if any of you have ever been in the position of being responsible for data quality, if your IT department or your technology group is the one that's responsible for making sure the data is clean, you are probably going to have a tough project. You really need to be in a place where you have your business users feeling some of the joy and need of keeping data clean, and also the pain if it doesn't, because if you don't have partnership with that, you're going to end up sort of having to follow other people around to clean up after them. Truth of data changes over time and by business need, so what does a country even mean, for example, if you have a country field defined in your database? If you had that and then the EU formed after you did that, well, wait a minute, now is it France, or are you thinking of it from a political entity in terms of the EU? And depending on what kind of transaction you're doing and what it means, those things might differ. So just keeping those meanings and tracking them can be tricky. And then I think the final point about changes in individual consumer behavior, we've all seen that this has radically changed how people consume media. That's a huge deal in the entertainment industry. So people cutting the cord, getting away from going home and viewing content on a time schedule. They want to view it on their own schedule. They want to, there's very different ideas between different groups and individuals out there, what ownership means and all those other things. So, and then options for copyright owners in terms of pursuing copyright infringement. So those are some of the non-technical concerns.
So from an NVC perspective, the things that we want to focus on now by doing this deep dive and understanding this is that a small problem can become a large one, and we don't have enough humans to take care of this problem. So automating, finding these problems, and then automating the cleanup is where we need to be. Also, we need to better target our business segments with this data and reach out to them. And our department, by knowing this, where the flaws of our data exist, can better target our next systems to find those things and squash them, instead of where we came from, which was initially CSVs and reports 10 or 15 years ago, been building up data and growing them organically. We can better target our systems by architecting them smartly. Thank you very much.
Thank you so much, all of you. It was a great speech indeed. So if you have any questions, if you want to discuss anything with three of them, you can catch up with them just around the building. So thank you so much for attending the session. Thank you.